Thanks, Emma, for the introduction. So, as you know, I'm Harshad. I'm a senior software engineer. I was also an intern in 2018. Started with Hema and others in the AICoE CI in the AICoE under the same team Project Dot. Um, from my start of my journey, I was working on a lot of projects in Project Dot. Then we started shifting and creating the CI and integrating CI. So here I am talking about that, and I hope you learn something from here for your internship. Let's continue. So let me just check this. Yeah, thanks. So today we'll go through why do we care about CI/CD, and then we'll see what design would we use, and how does the information flow through it. Uh, some implementation because we have created a separate CI for us, and then the other CI which we run, how it is set up, what it is, and then we'll conclude with based on that. Uh, so I'll go through like how AICoE is using CI and also how we set up it. And I'll also try to show you the real time, like how it works. So first question comes in is why do we care about CI/CD? So first to understand this, first we need to understand what is CI/CD. CI/CD stands for continuous integration and deployment. So the other part, the CD, is two halves of it. One which goes with CI, which is called continuous integration and delivery. So the delivery is the keyword which goes together, and the other CD is different, which is called continuous deployment. The part of the second half of it, which was continuous deployment, was yesterday talked by Humer, how it is used, how it has been set up in our ASUE, how it is being used. Example for that was Argo CD, where you create your application and then it gets deployed onto a OpenShift cluster. So that's a deployment where an application is being taken up and then put it then like containerized, and then it is being put into a cluster or to function from there. So the focus for today's talk will be on the first half of it, which is continuous integration and delivery. So continuous integration delivery is basically it's a point where the source code has been just written and now you want more updates to it. While you're updating, you don't want anything to break from your previous code which you have written because it's been tested and is running or executing in your cluster. So that's where the continuous integration comes in. Whenever you add new source code to your to the new changes to the source code, it has to be tested without breaking anything from the actual source code. So this is where the continuous integration happens. It checks, reruns whatever changes you're making and integrates it, checks it, and then if it is great, it will integrate that. The delivery part is where uh, so we are in the container world. So here the delivery works basically like you have the application gets containerized, and then it is delivered to the suitable place from where the deployment can take, the CD can take it up. So why do we care about it? Uh, we care about it because we want automatic test checking. We don't want, if you are making any changes, there's one person dedicated just to check uh, the developer's work. So this can be automated by doing CI/CD. This ensures validating. This ensures the no malicious code is going in your into the source code. This also helps you package, containerize, or basically sort of structuring it so that you can get that into a cluster. So CI/CD this CI/CD which we have designed, we wanted it to run on premise of OpenShift because we are on OpenShift. There are other CI/CDs which can run on other different cloud systems. So this is where we primarily wanted to focus on OpenShift so that our team can uh, basically utilize every inch of the cluster of OpenShift. So as you will see that projects based on projects, you have to define your CI/CD. Not all CI/CD can fit for all projects. Uh, when you're utilizing the environment, based on the environment, you have to see and absorb what kind of CI/CD will work for you. So there is, if you see the right side bottom corner, you'll see a diagram. It basically shows how a circle works, how it circles in that CI/CD pipeline. If there's a new source code, it gets checked, it is packaged and then deployed, and then again same thing happens for each and every changes. So going with this, I'll go take you through the whole journey. So earlier, all like most of the projects were monolithical. It means there was only one part of it. You write one whole project in one single application, and that you basically keep on doing that. But now, with the changes of container, like coming when the Kubernetes came in, and the application also became enhanced based on that. Now the projects are made monolithic, are breaking into microservices. So there could be 5 or 6 projects which are tangled together, and it becomes a project. So that's how it works. So when your project has become a microservice, you have to also configure your CI/CD based on that. Also, our like I said, as I said, like all our applications work on OpenShift, so it's a containerized platform. It's not a virtual machine, so it's not everything is not going into one single uh, hardware. It is being distributed based on where the cluster stays and into the containers. So that is another aspect which we need to keep in mind while running our application. So when the application itself is in container as well, we have to also configure our CI/CD to that word so that it works in sync. Uh, so this are some examples of CI/CD which were already existing or were being used. So in the VMware, in virtual machine world, there were Circle CI. You might have heard about these. So there's Travis CI, Jenkins, and the GitLab CI/CD. So these basically works like you have some dedicated servers. You open a pull request, for example, into your source code. The pull request basically gets a virtual machine is spun up, and everything is tested inside that. Uh, so this requires a lot of resources for a single project, uh, but we can segregate that into OpenShift world, the containerized world, and break it down into lesser resources and utilize the OpenShift power. So there came in the containerized based CI. The images you see there is Pro. It's a project from Kubernetes. There is Tecton. It's a project collaborated by the CI/CD Foundation organization, mainly contributed by folks from Google and Red Hat. And then there's Jenkins X. So the previous Jenkins was sort of changed and made into this form so that it can be used. It could be deployed on a continuous platform orchestration. So all the rest of the things which are in VMware are also or which are all virtual machine are also being changed to fit this. So if you see now, even the Circle CI will give you a feature for it to run on a Kubernetes orchestration. And as you can see, the trend is moving towards this. So everyone is moving towards the Kubernetes containerized world. So we also want to just keep on track and being sure that our application uses the CI/CD best for it. So our design was to check for something which is best for our use case. Most of the projects in COE is AI/ML based. So it's either models being deployed, models being created, or applications which are using some models inferencing. So most of the more projects are like that. So we wanted to cater to that. So what do we needed? We needed some, first of all, we needed checks, which is basically, so some checks basically would be syntax checking, linting checking. And then we also want some checks based on PyTest, like if the project is, if the new changes are being there. So based on that, PyTest testing, based on the code programming language, so any testing. Uh, So like that, we need some code checks. Uh, and then moving along, we needed the modules to be packaged into container images so that it can be used into the cluster and then delivered to the OpenShift environment. As we work in, so our team primarily works in Python programming language. So we normally release a lot of Python modules to PyPI. You might have heard about it. So when you do pip install X package, the package is basically pulled from an index called PyPI. So like that, we also wanted the CI to help the user directly upload these packages to PyPI so that it doesn't, so basically to stop all the manual processing and to automate it. So the developer can stay on focus on the source code and the application and don't need to worry about any DevOps stuff. So we have that, we wanted that feature as well. So while thinking about these things, we decided we should have our own pipelines where based on certain actions that does certain features. That's where we decided we need functionalities based on actions. So normally users, the interactions are on either pull request or on the repository. So pull request comes into place when some contributors are making new changes, and those changes are to be included into source code. So we wanted to trigger the CI based on each pull request so that it can do the checks and validate this pull request is good to be merged. And then the CI will merge the pull request and gets into source code. Now we wanted the release management for the repository. So we use the tag releases. When you release a application in the GitHub or GitLab, in any Git platform, it can be released with tags. And based on this tags, we wanted the CI to create the release. Uh, for example, if it's a module uploaded to the index, if it's a application, then containerize it, and put that into an image registry. So it's always an ongoing process on each pull request and on every release. So based on this, we decided to uh, work on this project and integrate it. So there were projects which are already there, but they didn't have the feature for building and pushing to the repositories, which push the image to certain image streams and then define those into our delivery pipeline. So we sort of thought of creating our own. And while doing that, we figured we need a pipeline. So from this diagram, you will see normally the source code goes into GitHub, and then from there it goes into deployment. But there are some missing pieces here. As you can see, something has to create the container image. Initially, the developer themselves used to create these images. So they used to containerize the image by themselves and then push it to an image registry. And from there, when they deploy it, they used to pull that. But this, as you can see, the lower half of it can be automated as well as I explained with the CI/CD. So we decided to create that half of it, and that's where the AICoE CI comes in. The AICoE CI is an implementation based on Tecton pipelines. Tecton pipelines, as I said, is a project from CI/CD Foundation. So this project gives you like tools to create your own CI pipeline. So as you can see, I'll first explain what Tecton does, and then we'll go through this whole diagram. This is just for your understanding, and if you want to contribute, this will give you much more better uh, understanding of this. So the Tecton pipelines are defined on four terminologies. There is the resources, then there's task, there is a pipeline, and then there is a pipeline execution. So so let's think it as a shell script. So in a shell script, what happens is the shell script itself contains lots of commands. So you basically write command to go into a directory, then run some tests, right? So think the shell script as the pipeline and the commands inside as a single task. Each task can do a lot of things. So that part can be known as a step. When you run this shell script, that is called the pipeline run. So basically, we are using a structure to define what tasks do we need to be fulfilled, and then set that in a pipeline and run that. So with this implementation, what we wanted is flexibility of releasing and also for the code test. So we created, so it works basically like this. You have your source code, you set up the bot, and then on each pull request, it will do some checks. And then if the check is great, if everything is green, then it will merge it. And when you release it, as I said, it will build the image, push it to a container registry for us, which Red Hat AICoE. And then from there, uh, we have also another step, which updates the manifest repository from where the Argo CD will take it in. So this is the flow we created. To set up this CI bot, uh, you you just need a repository. You can go to a link to this link, and it's a GitHub application, so you can just install it on your repository. Once you have installed, based on the as features you need, you might have to uh, add the collaborator, our bot, which is called Shashita. So it is also available in GitHub. You can just go and invite the bot to your project and then add a configuration file. We'll go into the configuration file details. You might have heard it from previous talks from Francesco, how this is being utilized in projects, but I'll go through the details. Uh, Once you have this up, it bot will take over and help you to maintain your project with the CI. So let's go into this details of this the configuration file. As you can see, there is the bit of called build and a deploy, and there was another bit check. I'll show it to you later when I'm doing the live thing. So build basically says how to build the image and where to push that image. So this information, when you're building from the talks of OpenShift, you would have learned like an image is created based on a base image. So here, a base image defines what image do you want to be used as a base image to build this application. So you define this information here, and then what type of build strategy. So build strategy can be a lot of different ways. There is sourced build strategy and there's Dockerfile build strategy. So you can define that. The CI will understand based on that, and then which repository or where which registry would you like to push it? So there is AICoE, like I said, we use AICoE, and then you have different organization in our teams have different orgs in registry. So we'll define that, and then you define your project name. And this registry secret is basically the bot secret which you would have enabled in the AICoE registry. Once you do this, you will the once you do this on every tag release, it will create an image and push it to AICoE. Then there is this deploy option. This we use Argo CD for deployment. So Argo CD needs manifest files. So this particular bit will deliver the essential aspects to that manifest file. So here you define. So here you define all the information of that manifest file, and then once the image is created, it will update the version or the tag number into that manifest file so that it can be deployed by the Argo CD. There was a question if we have unlimited access, one second, unlimited access to AICoE. As a Red Hat employee, you will have unlimited access to AICoE, and you can create any number of public repositories in our organization. Going further, like this is the dashboard. Like when CI runs, you can go to this dashboard and see what happens. Uh, so these all are single task. It's being based on each pull request it runs, and it will show you, okay, these are the changes, and this is happening. So you can come to a dashboard and also see the CI execution part of it. Uh, and all the information is posted to your pull request. So it's like commented on it if any issue comes in. So this is just a place where you can visit the CI and see what it is doing. This image you must have seen already from yesterday's talk by Francesco. Uh, as I said, like we concentrate on the AI/ML projects. So the projects, uh, so you build all the projects, and then the CI takes in and pushes that to image registry. And once you're done, the CD will do its part. So this is the part which we are concentrating. We check based on each model and then create an image for it. Another CI which we use is the Probe CI. Pro is the project created by Kubernetes community. It is also containerized based, so it also works on containers. It is written in Go. It is written in Go. So what we have shifted is the check part. We have used to do the checks. We have moved that part to Pro. So each check or the Pro or the jobs which you want to run on your pull request, you can define it by the Pro instance. What it The functionalities which we are using from it is basically the test on pull request, review like to set the reviewers on the source, like on the pull request, and then merging of that pull request. So these aspect is changed, is given to this, and the AICoE CI takes care of the release uh, and upload to PyPI. And there are other functionalities like yesterday, as you see, for the whole testing of ML model. So that is one of the features there. Uh, there is also another feature of overlays, which was explained yesterday. So these features are half and half defined. So here it takes care of the checks, and that can take care of the release. Pro instance can be installed for your application. So there is an instance which our project dot is running. It is deployed on operate first. It can be installed via webhook. It's already installed in all the AICoE organizations. But if you're creating another organization, you would have to create an access for it and install that. Uh, Configuration for each specific repository can be defined in a repository called Tot application. I'll put the link here. I missed. So it's a different repository there. You can set your configuration for your particular repository. And then, as I said, the checks runs for your pull request, you can define them in a file called pro.yaml. So before going to references, let me take you through the actual workflow so that you understand it uh, like in that way. So uh, do you see the GitHub here? So
Yes.
okay, thank you. So as you can see, there's two files here. So this is a template project. As you can see, the CI is defined in these two ways. Firstly, it's installed. So there is this installation where you go and you configure that to your project. So it's been already configured to this organization. Once it's done, as I said, you define AICoE CI YAML. As you can see, this is a template project, so everything has been uh, commented, but as you can see, it has checks, it has builds. So you basically define your build, what checks do you need. It also has a check called build check. Basically, it'll build the application with your source code changes. And if it builds, it will say it's good to be merged. Uh, and then there's this pro YAML, what I was talking about. Here you define each check of which you want. We use a pre-commit check. Pre-commit is sort of a multi-layered checking. It checks for a lot of things, file structure, file naming, from there to PyTest or MyPyTest, stuff like that. You can define it like this. All of this is already available in template projects, so you can create your projects from this or copy from there. Um, so same thing, this is for a normal Python application. Same thing for our friends from AS Ops has done for ML projects. So in ML projects, you would like that to be containerized into an image so that it can work on Jupyter Hub. So you can see the difference in here. There is a build script and a base image is little different. So you will basically not change anything. This will stay the same. The build strategy will be source to image. The build source script will say that I would like to build this into a image which works in Data Hub. So, and the image we already provide the base image for it. So you can utilize that and it will work for you, the directly work for you in the Data Hub. Once you have set up this, you can open pull request. So as you see, we have our own project. We have set up the pod. There is a pull request came in. On each pull request, the CI runs in. As you can see, this is from the pro job, each job, and if the green check is there, it means it's validated. And then there is a build check, which is checking based on that. And once you do this, there is a module which will check if everything is correct. It will merge it based on the approval. So once the reviewers are added, the reviewers must say, so the one of the reviewers says looks good to me, so a look good to me label is added, and then owner has to say approved. As as you see, someone else wrote approved, but they are not the owner. It prompted you are not the owner. Someone else has to do that. So once an owner does or maintainer does that, this pull request will be merged directly. Some pull requests can sometimes the CI checks get stuck. So how do you reset them? You do retest, /retest. All this is in the documentation. So I'll show you the reference so you can follow that. So once you do this comment, the CI will start up and it will try to do these changes. So as I said, we have our own instance of the pipeline. So this is the dashboard. As you see, the pipeline has started now. So this pipeline is starting now, and if you open it, it is doing some sort of testing, basically for the own CI. And at the end, once this every checks are done, it will start the build check for it. So you will see that in a second. It's just gathering all the resources and running. I can show you something which has already run, I guess. So this is for the release. As you can see, the release started. You don't need to worry if the color is red here. Some are just checks. The only main thing you need to focus on is like tag release. So this tag release run will have the information. So here, the project was ODH manifest. So they have released it. So based on that, there was some building happening. Once the build happened, they pushed it to this repository, and then we also send it for image analysis to run. I guess it would have run. Yeah, so it's still running. Once this completes, basically there would be updates in that pull request like this. Um, as you can see, it went to pending now, so it's still working on it. Same thing for these jobs. These jobs are finished, and so there is no nothing. But if they would have if they would have failed, you could have clicked on the details and you could have seen the issue and then fix your pull request based on that. I hope this helps you in your project, like while working on the projects in your internship. If you need any more details, you can go to these projects information, and this has all the documentation, like what you can do with the CI. So it helps you to do that. So one specific thing is the /deploy. What it does, if you write a /deploy here and comment that, what happens is it will build an image based on this pull request, and it will push it to your AICoE. So AICoE repository. So it will build on that. As you can see, this PR number. So this PR number states that it's an image based on this pull request. So how this can be utilized is you can use this image to put into your test cluster and test it out. So you don't need to create a release for it. You can create a pull request image and then just test it out. So that's how it is utilized. Uh, in Tot Station, like in our own project, we have this application, the Tot application, which I was saying here, all manifest file states. So when you try to deploy our application, like when you try to create an pull request based on an application, what happens is Our bot itself will update these manifests. So you can see here, there will be OLEs. This might be explained yesterday, but this is a structure of uh, customize. So you are using a tool called customize. So you define that, and then there is this image registry with image stream where this tag has to be changed. So if I show you some history, uh, think there should be very old, but these have some change. Oh, okay, sorry, test. Wrong file. Only test image registry. As you can see, there were times when we deployed by pull request and tested out. So you just do slash deploy. Everything gets automatically done by the CI. CI builds everything and then make a commit to this repository. And from here, Argo CD will take place and it will deploy for you in the test cluster and you can test it out. So this is just a method to show you, like you can use the CI in this way as well. Uh, I had this much. That's it for today. If you have any more questions, you can contact me. Here, I'm available on GChat, also in Slack from Operate First. So you can contact me there, and I have other information here. Thank you so much. If you have any questions, feel free to ask.
Thank you, Harshad. And do we have any questions for Harshad? Was he super clear? Yes, awesome. All right. Thank you again, Harshad. I'm going to stop recording and we can move on to the next session.
Thank you.